In order to understand anything more about B cells and cytotoxic T cells, we have to start by understanding the role of T helper cells. We said that T helper cells are the linchpin of the immune system, that when someone is infected with HIV, that it's that destruction of T helper cells that actually destroys the immune system and makes it unable to fight off infections. And yet T helper cells don't make antibodies, and they don't kill infected or cancer cells. So what the heck are they doing that's so important? Remember last time when we were talking about macrophages and dendritic cells, and we said that they are able to be activated by antigen-presenting cells? So we want to talk about how this works, because in order for your B cells and your cytotoxic T cells to do their job, we actually need to activate T helper cells first, because they're going to make chemicals in the form of cytokines that will activate the other cells in the immune system. So let's talk about how this works. I've got a complicated slide here, but we're going to go through it really slowly so that you understand this process. I want to take you back to our innate immune system lecture, and we talked about phagocytosis. We said that macrophages and dendritic cells, I've added this here, macrophages are able to phagocytize a microbe. They're going to take it up in a phagosome. It's going to become a phagolysosome. The microbe's going to get chopped into little pieces like an angry medieval warrior, right? And then what's going to happen in a macrophage or a dendritic cell? Well, the pieces are going to get presented on the surface of the macrophage or dendritic cell. And when we talked about the spikes, now you're ready to understand that these spikes are these MHC class II molecules. Remember we said these were professional antigen presenting cells, so they have MHC class II. That's what this self-protein is. So this MHC class II will bind to the foreign antigen. It's going to put it on the surface, right? And it's going to, in the lymph node, travel to T cells and B cells and show it to everybody. And what it's really looking for is a T cell receptor on a helper T cell that has just the right shape. Remember we said you can make billions of these, and somewhere in the universe, an antibody will be available, or a T cell receptor will be available that will bind to every known possible shape that we believe can happen. So here we have our helper T cell receptor. It's binding to this particular antigen presenting cell. It's binding to the MHC class II with the antigen on it. And when this happens, the antigen presenting cell, because of this binding event, it will make a interleukin 1. And this interleukin 1 will actually help stimulate the helper T cell. Okay. Now we also, once the helper T cell will also respond to this interaction, it's going to make interleukin 2, and that has an autocrine response because it's going to cause the cell itself to begin to divide. Because we know this is a part of clonal selection. We're activating this particular cell. It's gone from being a naive helper T cell to being an activated helper T cell, and it's going to divide into many, many, many copies. Now, when it does that, this helper T cell is then available to activate other B cells that also bind. See how it has the same shape? So it's going to send chemicals out to bind to B cells and stimulate B cells that will help secrete antibodies against this antigen. And it's going to stimulate chemicals that will activate cytotoxic T cells in case this antigen is present on infected cells, okay? So this helper T cell, once it's activated, is going to be responsible for activating B cells and cytotoxic T cells. But it has to get activated first. So if you don't have activation of the helper T cell, it doesn't matter if you have the right B cells and cytotoxic T cells in your body. Without these cytokines and interleukins, these cells won't get activated. So we come back to our patient who might be infected with HIV and they have very few helper T cells. The rest of their immune system collapses along with their helper T cell count. Helper T cells really do quite a bit. So this actually breaks it into 3 phases. So one of the things that they do is antigen recognition. Here's, again, just another picture of the same thing we just talked about. An antigen presenting cell, a dendritic cell or a macrophage, phagocytizing antigen, chopping it up into little pieces, putting its head on a spike, which is our MHC class II protein, The helper T cell with just the right T cell receptor will bind. This interaction results in the secretion of cytokines and interleukins, and those are going to cause this cell to divide into many copies. And there are different kinds of copies as well that have different jobs. So some of those copies will become memory T cells, and they're going to circulate long-term in your body to protect you against this particular pathogen if it ever shows up again. Some of these helper T cell effector cells are going to secrete chemicals that activate your innate immune system. So they're going to really stimulate neutrophils and macrophages to continue fighting this infection. Some of those chemicals can stimulate killer T cells into destroying infected cells, and some of those chemicals, those cytokines and interleukins, will activate B cells. All right, so helper T cells, one of the critical thinking question is name 3 ways they're helpers. And here you go. They stimulate the innate immune system, they stimulate the cell-mediated response, and they also stimulate the humoral response of the adaptive immune system. All right, I keep promising that we're going to talk about B cells, and that's up next. Now that we've learned all the pieces of how a B cell works, we're going to talk about how they get activated in more detail by a helper T cell.